Okay. So hi guys, thank you for coming. My name is Mario Fusco. I work for Red Hat. I work on Drules, which is the rule engine of Red Hat. And a couple of more words about me. I am the co-author of this book. So if you are looking for a good Java book, look no further. This is of course the best one. And I'm also one of the organizers of the first Vox days in Italy, in my town, in Milano. So if you are a speaker or if you want to try to be a speaker, don't be shy and help us to have a great Vox days. Submit your passions and your call for paper. Okay. Okay, so my talk started from this joke that I found on the internet, and probably you have already seen this. It's about we have a lots of pattern and principle that we follow in object-oriented programming, and then the joke is about, okay, you don't need all this stuff. If you do functional programming, everything is a function and you will be fine, okay? And I did something similar actually a couple of Devoxx ago. I don't know how many of you were there, but anyway, I did a live programming talk where I took some of the Gang of Four patterns and with the traditional object-oriented point of view, and I translated them in functional programming using the Java 8 Lambda. So I contributed to this, okay? To the joke, let's say, which is a joke because it is creating, I found that it was creating a false dichotomies between object-oriented and functional programming. And then reflecting on this, I found that in this particular historical period, we live in a world of false dichotomies. I'm from Italy, and I don't know if it's the same here in North Europe, but in Italy, the political storytelling in this period is all like this, okay? If you want to make the market and the investors happy, you are against the common people for some reason. If you want to help the immigrants, why you are against the local and want to help the immigrants. And if you want to promote the international agreement, then you are not, you are against your country for some reason. And if you want to have a better environment, you have to choose. Either you have a better environment or you promote the industrial development, okay? So we live in a world of false dichotomies. And they are indeed false, because there's no reason why this thing shouldn't coexist in the happily coexist, okay? And why do we live? Why this false dichotomies argument works on us? Because our brain is lazy. We are lazy, okay? If somebody asks us, you have to choose between A and B, guess what? We will choose either A or B, okay? But this is in the biggest part of cases, this is wrong. Okay, there could be a option C that we are not evaluating, but I'm not speaking about this now. I'm saying that you don't have to go 100% A or 100% B. Maybe, very likely, you can find a good mix of the two. And if you find a good mix of the two, one thing could probably reinforce the other. For instance, without the immigrants, our retirement system will blow up in a decade, probably. So these things can not only compete, but they can work together. There are synergies between these things, okay? And false dichotomies are also simple, too much simple solution for complex problems. So we live in a complex world, and simple solution doesn't work. And of course, we do a complex job, and simple solution often doesn't work. And so as much as we have false dichotomies in our world, we also have false dichotomies in software engineering. So we are asked to choose between SQL and NoSQL databases, but probably we need both point of view, or many NoSQL databases can be queried in SQL, for instance. So you can have both point of view, and you can take advantage of both worlds. In the same way, we are in a world where we're speaking a lot about monoliths versus microservices. But what is a microservices? Which are the boundaries? How big, how micro has to be a microservice? How big has to be? It should be just one single function, one single method call. It could be a bit bigger. The border is blurred, okay? And another thing, as I said, I work on Drules, which is the rule engine of Red Hat, which is the old style artificial intelligence. And now they are telling us, this is just old, you just need the machine learning, and with machine learning you can do everything. Okay, great. And then last week I bought this phone on Amazon, and 2 days later I got an email from Amazon. If you are interested in this phone, maybe you are interested in these other 3 phones. And how much are how much is likely that I want to buy one more phone because I just bought one? And why this is happening? Because it's all machine learning. It's all statistical correlation. Of course, this article is statistically related with other phones. But if you apply some common sense or some business rule that says, okay, this guy just bought a phone, don't suggest him another phone. Maybe suggest him a cover, or I don't know. And this is just common sense, and you don't want to reinvent the wheel by throwing all your business knowledge away and making the machine learning to rediscover it from scratch, okay? So there could be a balance between all these things. And of course, there could be a balance between object-oriented programming and functional programming, which is the topic of this talk, okay? So why also these false dichotomies has been created? Because we have some old knowledge about what object-oriented programming means and what functional programming means that doesn't match the reality, or doesn't match the reality anymore, okay? So for the old developers like me, this is object-oriented, okay? So it's that book with all those fancy patterns, and this will lead us to create software that resemble this stuff. So you have this fancy factory and manager and initializer and interfaces and decorator and whatever, okay? And this is, I guess, a well-known quote of Alan Kay, which is the father of object-oriented programming. And he said, actually, I made the term object-oriented, and I can tell you that I didn't have C++ or Java, which is the same thing, in mind. And in reality, if you think about it, how we are used to think about object-oriented is a big misunderstanding. It wasn't supposed to be that, okay? How object-oriented turned out to be implemented in C++ and in Java is more class-oriented programming. Originally, object-oriented programming was what has been implemented in this Smalltalk. You have an object holding the state, and the state is private to that object. It's not visible outside. It's not shared. You don't have a shared state. And what the object did is communicating with messages, and each message could cause the change of the internal state of the object or the sending of other messages to other object. Which, if you think about it, this is exactly what the actor model is, for a reason. Okay, so this is what was object-oriented was originally. And so there are some myths about object-oriented. In the same way, there are some myths about the functional programming. We think that is the new thing, but actually it's not new at all. As Venkat said during the keynote this morning, it's something that is born in the 30s. And if you think about it, Haskell is 5 years older than Java, actually. And once again, we think that we speak about object-oriented or functional programming as a well-defined thing. But what does it mean to do functional development? Is using lambda enough? Do you need all the mathematical structure as abstraction? Do you need all the purity of a pure programming language like Haskell, or is something in the middle like Scala? What does it mean? So it's not well defined. And in the same way, again, there's no dichotomy. It's not the opposite of object-oriented. There are some principles in object-oriented that are good in abstract. In the same way, there are some good principles in functional programming. And guess what? In 99% of cases, these principles are totally orthogonal. So you can combine them. You can leverage both. Another myth is that functional programming is hard. And probably the biggest part why this myth exists is a matter of familiarity. I started doing development more than 20 years ago, and in the past, the biggest part of the last 20 years, I've done object-oriented programming, so I'm really much more familiar with this. Of course, if I do functional programming, I'm doing something that is quite new to me, so I feel that it's hard, but probably it's just less familiar. Functional programming is less efficient. This is another myth. There is some truth, but the truth depends on how functional programming is implemented. With the current implementation of functional programming, yes, it is slow. For instance, it is slow on the JVM. Why this is slow? Because typically you create many more objects, and then you are putting more pressure on the garbage collector. That's true, but this is just an implementation detail, and probably it's something that a good compiler could fix for us. Okay, so it's just the effect of how Java and the Java virtual machine has been implemented with object-oriented in mind. Okay, another myth: functional programming is only good for math. This is not true. You can go do pretty nice user interfaces with functional programming, for instance. If you think about functional reactive programming, you know what I'm speaking about. And again, it's not an all or nothing game. You can mix with other programming styles, and this is one. I believe this is one of the most harming myths. If I do functional programming, I'm doing great code, I'm doing great. No, trust me, you can write crap also with pure functional programming. You can develop bad code also in Haskell. Okay? So, said that, let's move on from the myth, and let's stick with the common definition of object-oriented programming and functional programming. So from now on, object-oriented programming is just what we are used to think. So it's object with some data fields, with some data, and some associated procedure, methods that operate on the data, okay? So object-oriented programming is based on this, while functional programming is the is based on the evaluation of possibly a pure mathematical function and the composition of them, which is important. Okay, so what is the difference between the two? Under not semantic but syntactic point of view, is just this. Okay, with object-oriented, you have an object and you call a method on it, and with functional programming, you have a function and you pass an argument to the function. Okay, but this is just a syntactic difference, not a semantic one. And indeed, probably we should write this in the Lisp way. And the Lisp way underlines the fact that data and computation are actually the same thing and are interchangeable. And this is the principle, if you think about it, on what MapReduce is founded. How does MapReduce works? Why it's so fast? Because we can choose if you want to move to a given node the data, or if you want to move the computation. And actually, data are a few, in common cases, data are a few gigabytes or data, while a function and method is 1 kilobyte. So if you can use them in the same way, and you have to move one of them, which one you move? You move the function, you move the computation, okay? But you can do this only in the moment when you understand that data and computation are actually two faces of the same thing, okay? But actually there is a difference, and the biggest difference, which is also the biggest advantage of object-oriented programming, is the polymorphism. So what is good about the polymorphism? The fact is that when you use it, you don't create a source code dependency from the caller to the callee. Okay, and we can better understand this advantage by comparing object-oriented and functional decomposition. So let's suppose we have a few kind of data object, and a few operations that we want to implement on them. Okay, so if we follow an object-oriented decomposition way, each class is one row, okay? And for each class, we will implement one of the column, one of the method, okay? Conversely, if you want to do a functional decomposition, you will start from the column, and for each function, you will implement a different behavior based on the fact that you are passed with a different kind of object. Okay, what does this means in code? In code, this means that this is the classical object-oriented decomposition. So you have an interface which just declares the behavior that you saw in the former slides, and you have different implementation. Okay, so so what's the winning point of the polymorphism? It is the fact that if you want another class object implementing the expression interface, the expression interface doesn't have to depend on the object. So again, the color doesn't depend on the callee. And this is not the case in functional programming, because in functional programming, I have this expression, and I have these three functions which implement the eval, the s0, and the string function. And based on the fact that I'm passed with an int, with an addition, or with an negation, I will do something different. But this means that if I want to add a new object, the function will have to depend on that object. Okay, so this is the winning point of object-oriented. Which one is better? Okay, one aspect is the polymorphism, but if you if you don't have any dependency problem, I think that both patterns could be interesting, could be useful, in my opinion, but this is just my personal opinion. If you have to write an interpreter, probably the functional decomposition approach is more natural. Probably if you are developing a graphical user interface, then you want to bind each behavior to the object that generated it. So probably the object-oriented decomposition it's more natural in this case. But it's just a matter of finding the right tool for the job at end as usual. As usual, if you only have an hammer, you will start in hammering everything, and this is not a good thing. So you just have to know that you have both options, and you can choose between them. So we spoke about composition. So the next natural step to me was to, okay, let's say something about also composition. But in reality, with functional composition and object-oriented composition, we speak really about two totally different things that are not comparable. Because functional composition, I guess, is clear for everybody. You have a function f, and then you compose with a function g, and then the result will be the application of the result of the application of f passed to g and applied to it again. So you are just composing function. It's the natural way of doing functional composition. With the object-oriented, you actually have two mechanisms to do composition. One is the inheritance, of course, and everything start in a clear way, and then if you push the model forward, the things becomes much more complicated. And actually, the other mechanism, which is probably the better one of the two in the most cases, in the biggest part of cases, is the association. And usually, you implement association with dependency injection, which work almost always, so provided that you are injected with the right thing. Okay, so these are two concepts again that are not really comparable. So we spoke about some object-oriented advantage. The biggest, the elephant in the room for what regards the functional programming is the immutability, okay? And you have a lot of advantages of immutability, as you probably already know. The immutability is more thread safe because you don't have you are not mutating state, so one thread cannot change the state of a value while another thread is trying to use in it. So this, of course, will improve the parallelizability. If everything is immutable, also caching will be easier because you will not have the cache invalidation problem. And under a developer point of view, it's easier to reason on the code or reason on code which is immutable. So it's easier to enforce the correctness of what you are doing. The code, it's more consistent and better encapsulated. So immutability has lots of advantage. Again, of course, on the Java virtual machine has some this performance cost. Why? Because with immutability means that you are, instead of mutating an object, you are creating more and more objects, okay? But this is an implementation detail. So, okay, this is another very known quote. I guess Venkat mentioned it yesterday. So this is one of the big difference on this regard between object-oriented and functional programming. The first one tried to reduce the complexity by encapsulating the moving parts, while functional programming tried to minimize or avoid at all the moving part. Okay, but again, this is a a principle that is more natural in functional programming. But nothing says that you cannot do object-oriented programming and have everything immutable. Okay, so the two paradigms cross-pollinating each other. If you can use the good idea of one programming style with the other. So we found that, especially now that we do a lot of multi-threading programming, that mutability is a winning thing. Why we should confine it into the functional world? Let's also use it in the object-oriented one. And if you push forward the concept of immutability, the next steps is doing referential transparency. What does it mean with referential transparency? It means that if a piece of code is referential transparent, you can replace, always replace that code with the result of the execution of that piece of code. Okay, so this means that that piece of code, for being referential transparent, not only has to be immutable, but also it doesn't have to be any side effect. Okay, meaning that if you expect that every time that the method is called, you will have something printed, and then you are caching the result, you are not executing the method anymore. You are replacing the method execution with the result. You will not have the printout anymore. So being referential transparency is not only immutability, but also not having side effects. Okay, and one of the typical examples to compare the two is by comparing, for instance, the string with a string builder. The string is immutable, so you can always replace the value, the method invocation with the result of the method invocation. But the string builder instead is mutable. So if you try to do the same, if you do the same method invocation twice, you cannot replace the result with the method invocation because it's not referential transparent, and if you do so, you will end up with the wrong result. So referential transparency is another winning point of functional programming, and it's a winning point both under a developer point of view, because if everything is referential transparent, you can use the substitution model, meaning that you can, at least in your mind when you are developing code, also always replace the result of a method invocation with the result, with the actual value. Okay, and it's a winning point also for under a performance point of view, because the Java virtual machine can do some internal optimization. Again, you don't have moving data, so you don't need synchronization. And again, having referential transparent code, meaning that you also always cache the result safely. Okay. Another big difference between traditional object-oriented development and functional development is how we do error management, supposing that there is an error. Okay, so what's wrong with this signature? In my opinion, the wrong part is that we are throwing an exception for a situation that is not really exceptional. Okay. I want to parse a string and get an int out of it, and many times that string is not representing an int. Okay, so there is nothing exceptional in this fact. I shouldn't be reported of this with an exception, with an error. Okay, and going back to concept of referential transparency, also throwing exception is a side effect. And what's the problem about this? Is that I cannot do caching, I cannot use memoization. Instead, if you replace the exception with this signature, you have a big advantage. Why? Because now you can cache the value, you can cache the result. If a string is not a parsable int, you will get just an empty optional, which is a value, and you can cache it like any other value. And trying to parse a string which is not an integer will not blow up your code. It's a cacheable result, the empty result. So I'm not saying don't use exception, but I'm saying exception are for exceptionally use case, okay? Which is much more rare than what we think, okay? They are a sort of glorified multi-level go-to. Sometimes we want to do this, but we want to do this only for really non-recoverable error. Not always, okay? Another example. Last year, I spoke about laziness in Java, and I showed this example among my slides. What I wanted to point out here, I have this object-oriented style code, the imperative style code, which is parsing a file, and I wanted to find in this file the first 40 error lines in a log file, okay? So this is the object-oriented solution on the left. On the right, you have the functional programming solution, which is much more concise, much more compact. And what I wanted to show is that it's not only the fact that it is more compact and more readable, but with the color, I wanted to underline the fact that you have clear separation of concern, okay? In the functional solution, every lines have a different, is doing something different, have a different concern. The first line is traversing loading the files and traversing it. The second is filtering the lines with the error condition. The third is limiting to the first 40 result. And the fourth is collecting the error lines into a list, okay? And the corresponding code in the object-oriented solution is all scattered around, okay? So I believe that in this case, the functional solution is a clear winner here, maybe. So we have this beautiful code. What a beautiful code, right? And then a friend of mine came to me, okay, your solution is beautiful, but I have a different requirement. I don't want to log only the error lines, but I want to log all error lines and the line before it. Okay? And when you get a requirement like this, it's something like this happens. Okay? You have your perfect code, you have the perfect solution, and somebody's throwing a Mentos into it. And yeah, let's try to do this exercise together. Let's try to change the code to fulfill the new requirement. The object-oriented version, it was not so beautiful before, but with a small addition, which is the previous line. With a small addition, we can fulfill the few requirements. So I'm not taking count of the current line, but I'm also in the while loop, I'm also recording the value of the previous line, and then I'm combining the two into an array, and I'm done. With a small change, I fulfilled the requirement. And things are not so easy with the functional version, of course. This is one solution that they came in mind. So what I'm doing is that I'm traversing the stream once, and then I'm creating all the pair of lines, pairing one line with the subsequent one, okay? And then I'm traversing this list of pair a second time, applying the filtering and the limitation and collecting them, okay? So, but this is very ugly under a functional, also under a functional point of view, because also I have mutability here, and I have to read the whole file in memory anyway, okay? So this is very ugly, and this is probably a better solution. So for some reason, we don't have a zip method in the stream API, but it's not that hard to create one. What does this method does is taking one item of the first stream, one item of the second stream, and pairing them and creating another result with this by function, okay? So I created this zip feature with just 2 lines of code. And then what I'm doing, I'm creating, I'm combining the log files with itself, but creating an offset here. So, the first stream has an offset. So when I zip them, I will have the effect of combining the one line with the subsequent line in the file, and then I can do again the filtering, the limiting, and the collect. Okay, so this is a better solution than the one before. But what is the problem? The problem is that yeah, it is nice. It's not that bad, but I had to rewrote everything from scratch. I had to change everything. While with the object-oriented solution, I just added 2 lines of code, and everything was okay. I have to. This piece of code took me a couple of hours to get it right, and again, I had to rewrite it from scratch. It's a totally different solution than the former one. Okay, so we have seen a few false dichotomies between object-oriented and functional programming. So we have seen the advantages of polymorphism against the functional decomposition. We have spoken about immutability, about the fact that you should use the exception very sparingly. The difference between imperative and declarative. I'm a fan of functional programming, as probably you know. I'm a fan of declarative programming, but I wanted to be honest. I also wanted to show you this time one situation when it's not all only flowers and rainbows. Okay. And there are other differences between these two approaches. We have the stateful versus stateless, which is more typical in functional programming. And related to this, we have how we do asynchronous computation using threads or future. And then we have statement or expression or iteration versus recursion. Let's also go through this quickly. Regarding the state versus stateful and the use of threads instead of future, the two things are very related. So in my example here, I wanted to show to the user the price of one item in one shop. So I load the item from the database with one method, which is not implemented, but let's suppose it's a long-lasting method that has to do a call on the database. So this one method will fetch the price of the item from the database in US dollars, and then I have to call a remote service to know the conversion rate between the US dollars and the currency that is used by my user. So this is actually doing the job. So it's loading the price in US dollars of the item and multiplying it by the conversion rate. But the first call is a call to the database. The second call is a call to a remote service. So probably both will be slow. And what we want to do is run them in parallel, of course. So let's try to do this with a thread. So I'm hoping you are not using thread this way, but in reality, okay, this is a trivial example, but in reality, this is what actually do with threads. We have a shared mutable state, which is this result, okay, and then we have two threads running in parallel that are both mutating the result, okay? So to make sure that the result is consistent, we have to make sure that the access to the value, to the shared value is synchronized, okay? So what's the problem here? The problem here is that it's the state, it's the shared state, okay? And it's a very common problem with the object-oriented programming because the state normally is a quite big graph of objects. So as Joe Armstrong said, you just wanted a banana, but then you get the gorilla and the whole jungle with it, okay? Because all the state in your application actually usually forms a complex graph. So it's very hard to find the boundaries of an object and to figure out if or if not a thread is changing the value that is used by another thread, okay? And of course you can do better with completable future and with the callback. So you can have two async computation and then you can combine them and you have no shared state. This is much easier, this is much more understandable, and you are done. But again, this is the nice case, but you know what happens when you do callback more and more and more. You have this effect that at some point the code is really not understandable. So again, of course, in this case, my favorite solution is the second one, but there are pros and cons in both. So I'm not, in all this example, I'm not saying go with solution one or go with solution two, okay? I'm trying to show that both solution one and solution two has pros and cons. Of course, we live in a complex world, sorry. And you have to be aware of the pros and cons of both solutions, and to choose between it and combine them if you can, and if it works for you. Okay. There are other minor differences between object-oriented and functional programming. One is that with functional programming, you also always try to do expression. So you also always have to call something that has a result, okay? While you have lots of statement in object-oriented programming like you do in Java. And I, of course, prefer the expression version, but this is, yes, you can choose between the two in case of the if-else versus the ternary operator, but in most cases it depends on the language that you are using, so probably you cannot do much about this. Another thing, this is a discussion that I had with a friend who is a functional Taliban. No, you don't have to use the iteration because you shouldn't use the iteration because you are mutating some state at some point. The perfect good way to do this is recursion. Okay. Yes, but to be honest, I'm a pragmatic person. Okay, I know that with this for loop I'm mutating some state, but it is confined in this small method, and I have no shared state, so I'm not doing any harm. I want to use the most clear solution. I want to use the iterative solution, probably even better the stream version, the internal iterative version. Okay, this will have some mutability that in the case of the stream version is hidden under the hood, but yes, I'm a pragmatic person. The iterative version are much more readable, and I think they are also much faster. And in Java, you don't have the tail elimination yet, so if you have a very long sum, you will blow up your stack. So there are lots of good reasons to be pragmatic and to go with the object-oriented solution. So I found this not long blog post which advocated that you should combine them, but by doing functional programming in the small, meaning using functional programming for the small calculation part, and object-oriented programming in the large, meaning that using object-oriented pattern for the coordination of the part of your architecture of your software. But to be honest, I believe that yeah, this works, but probably also the opposite is reasonable. You can use the functional programming to orchestrate in a functional stateless way the different part, the microservices part of your architecture, and use object principle that are probably more readable, better understood in the small, where concurrency is doing no harm. So again, I'm trying to tell you, be pragmatic. Both point of view are okay to me, and every mix of them. So there is no silver bullet. Just try to take the best of the two worlds. Okay, and taking the best of the two worlds, meaning that I started doing object-oriented programming. Then at some point in my life, I started doing Haskell and Scala, and I became a functional Taliban myself. And then I saw that probably this is a more, I'm getting old, you know, so when you get old, probably you try to avoid problem and to be more pragmatic, and then the pragmatic way is this. It's not 100% functional. It's probably not even 98% functional. You will get mad if you try to do this. And in the same way, okay, you do unit tests, but you get mad if you want 100% test coverage. I know some of you is trying to do, look, I have this cobertura report, I have 100% coverage, but it's not really useful, and you get mad if you want to get there, okay? So you just be pragmatic. 80% or 85% of functional style of immutability is good enough. And which is the programming version of perfect is enemy of good, which is a quote of Voltaire. Okay, so to recap, object-oriented plus functional programming doesn't have to look like this. Okay, can look like this, but doesn't have to. And the key takeaway is that with object-oriented, pure object-oriented programming, you have a way of looking at your software that is based on the object, on the knowns, on the facts, okay? And with functional programming, you have a point of view that is more based on the verbs, on how to process them. But in reality, in any software, you need both. So, and if you think about it, there is no longer also in programming languages a clear boundary between what is functional and what is not. Is Java 8 a functional language or not? And yes, being a polyglot programmer is good. You see a lot of languages. But using more paradigm, it's even better, okay? I went from Java, then I did some Scala, and I met a lot of people doing Scala exactly in the same way as they did Java, which is pointless. So they are they are polyglot, they are multi-language developer, but mono-paradigm developer, which is the wrong way the wrong thing to do, okay? So be pragmatic. If you come from object-oriented, study functional programming. If you come from functional programming, study object-oriented, and use both. Okay, I'm done. And